The numerator in the z-score test statistic measures which of the following? A, the expected difference between the sample mean and the population mean, given that the null hypothesis were true. B, the actual difference between the sample mean and the population mean, given that the null hypothesis were true. C, the difference between the sample mean and the critical region. Or D, whether there is a significant difference between the sample mean and the population mean or not. So to make sense of this, we should have a look at the formula because we need to identify the numerator. The numerator is the top of a fraction, and z is made up of a fraction. The numerator is the sample mean minus the population mean, or this is the before treatment mean. And on the bottom, I've got my standard error of the mean. So the numerator is what we're focusing on there, or in this question. So let's have a look at what the numerator is doing. The numerator is, in fact, measuring a difference. Subtraction means you're finding the difference between two quantities. So I can rule out D here. D says whether there is a significant difference between the sample mean and the population mean or not. Notice this one's worded a little bit differently. The first three are talking about it being a difference. But in D, they're talking about whether or not there is a significant difference. So D is sort of a yes or no. Is there a difference, or is the difference significant or not? That's something that Z does when we use it within a hypothesis test. But that's not what just the top or just the numerator of the fraction that makes up Z does by itself. This is measuring an actual difference. It's a difference between two quantities here. So it's not whether or not that difference is significant, it's measuring the difference. So which one of these differences is it? Well, you can see that it measures the difference between these two quantities, the sample mean and the population mean, so it's going to be either A or B. It's not between the sample mean and the critical region. So I can rule that out there. So which one of these is it going to be? Well, let's have a look at what they're talking about here. It says, given that the null hypothesis were true. The null hypothesis always tells us that the treatment has no effect. Okay, so if the treatment has no effect, then my before treatment mean is the actual mean of the population that I'm studying. And what about this one here? What is this? Well, this is my actual sample mean. So if the null hypothesis is true, this is not simply just a hypothesized value. This is the actual population mean. And over here, I've got the actual sample mean. So when I subtract one from the other, I'm going to be getting B, the actual difference. Not some theoretical or expected difference, but I'm going to be measuring the actual difference between the mean and the population mean, the sample mean and the population mean. So my answer here is B.